So compiling code refers to the process of turning our code into data that a computer can understand. So we have to define a few terms. First is digital data and computer. So a digital computer is an electronic device that processes data and performs calculations using binary data. Contrary to maybe your beliefs or to your knowledge, the first computer was not digital. It actually worked via hand crank. You had to crank that computer. That was Charles Babbage who created what is widely recognized as the first computer. But computers nowadays, of course, are all considered digital computers. So they're electronic, right? And they're working with zeros and ones. Why they're working with zeros and ones? As you can see in this little icon right here, the 101010. That is the language of computers. So first, let's talk about what binary data is. So binary means composed of two parts. Um, for example, bicycle, right, means two wheels. Bipedal means uh, organism, right, that walks on two legs. Well, binary is just meaning two parts. Well, what are the two parts we're talking about when we're referring to computer data? Well, digital computers can only understand two states, off or on. Of course, nowadays we're moving into like quantum computing, and now we're like exploding the number of states that a computer can handle. But when we're talking about digital computers, it's just two states, off or on. So off we represent by a zero, which makes sense, and on we represent by a one. So we use these numbers to represent the binary states of on and off. So here, a little diagram. Whoops. The electric charge is on. That would be represented by a 1. The electric charge is off. That would be represented by a 0. And that's because computers run on chips, right? On electric circuits, on real hardware, right? And this hardware works with electricity, and electricity, right? You could really either just be on or off. So machine code, which is the language of computers, is written in binary. So binary is the language of computers. If you do, go further along in your computer science journey, you also learn hexadecimal, another way to represent data in computers. But yeah, at the lowest level, for the most part, computers are working in binary. So the natural language of computers is binary. So the data input to a computer, whether it's from a keyboard, another program, USB drive, game control, anything you can think of, is going to be read by the computer as binary data. So binary digit, those zeros and ones, we call it a bit. Binary digit, you shorten it, you get bit. So that is the smallest unit of data that a computer can read. We do group these bits together in a meaningful way. So just like we group letters together, right, to form words, well, we group these bits together to form bytes. Specifically, 8 bits is usually referred to as a byte. The reason being, it just kind of became a standard when computers were being innovated, developed, advanced. 8-bit byte became the standard because there's good balance between memory efficiency and processing capabilities. So text, the word hi, is actually represented in 16 bits or 2 bytes. So the letter H is 1 byte, the letter I is 1 byte, and 2 bytes times 8 is 16 bits. There's a system called ASCII that actually describes how to convert from decimal numbers. So those are numbers that humans use. By the way, the reason we have a decimal system or a system of 10 is because we have 10 fingers. So that's why we go by a system of 10. So if there's like an alien species out there and they only had 8 fingers, they'd probably be counting similar to how these bytes count in eights. Funny fact or a little fun fact about number systems, the ancient Mayans actually would do a system of 20 because they would use their toes as well for counting. So these number systems completely made up, but when you have them follow really strict rules, just like programming languages do, you can do really amazing things, such as represent different number systems and jump between them. So think of computers as only having 2 fingers, right? They can only count on or off. Well, humans, we go up to 10, but you can translate between these number systems. In fact, if you take discrete math, that's kind of like the math for computer scientists, you do learn how to translate between these number systems. But yeah, so ASCII, you have text, goes into a decimal number, eventually can be converted into binary. So this is how computers would read it. So computer would read the word hi as 010, 01000, 01101, the letter I over here. And decimal, that'd be 8 and 9 according to ASCII. Completely made up system, right? But it's one that we use widely. You can also encode images, right? Because the images on your screen are just pixels. They're little squares, right? Especially if you go to screens from yesteryear, right? From a long time ago. You could actually see the pixels, right? You played Super Mario. You could see Mario was just a bunch of little boxes. Nowadays, our screens have millions of pixels, right? To make that image look really crisp. And it's almost indiscernible, right? To our eyes. Once we get to those like 4K, right? I don't know, maybe they're getting to 8K at this point. That just means it has a ton of pixels. Well, those individual pixels could be represented with binary numbers. If you're doing just black and white, it's pretty simple. 1 is on, so that pixel would be on. If you wanted a black pixel, you'd go with 0. You'd turn that pixel off. If you wanted more colors, then you need more binary digits, more bits. So now white is 1, 1. Red is 0, 0. Orange is 0, 1. And yellow is 1, 0. So yeah, the more data you're trying to encode, right, the more complex, the more binary digits you're gonna need. We've talked about bytes. Just a little slide. So this is actually directly from my 101 class. We do a little activity there called binary charades. But yeah, bytes, we have our bit is the smallest unit of data. We actually have a name for 4 bits. We call that a nibble. 8 bits is called a byte, as we discussed. Once you start getting into the order of the thousands, right? 1,000 bytes, we get to kilobyte, and then 1,000 kilobytes roughly, right? It's going to give you a megabyte. 1,000 megabytes going to give you a gigabyte. 1,000 gigabytes going to give you a terabyte, so forth and so forth, all the way to something called a yottabyte. I can tell you the biggest memory I work with is terabyte. I have one of those for my like photography files. Those are really big, so it's useful for having a place to store them so I'm not clogging up my computer. So here's a little bit of a history of programming languages. Highly encourage you to watch it. It's from Byte of Michael.